7.4 Equations for Chemical Reactions. A chemical change occurs when a substance is converted from one or more new substances that have different formulas and different properties. In this section, our learning goal is to write a balanced chemical equation from the formulas of reactants and products for a reaction, and then determine the amount of atoms in the reactants and products. That way we know that we've balanced it. So many different kinds of chemical reactions. Just something so simple as iron rusting is an example of a chemical reaction because iron, Fe, is reacting with the oxygen in the air to give us our iron 3 oxide, which is rust. Now then, when we write a chemical reaction, notice here we have a reactant on the left-hand side of our equation, we have an arrow, and we have our products. So in writing a chemical equation, an arrow separates reactants from products. So let me go back and show you. You will notice we have this arrow that separates them. Reactants are written on the left side of the arrow and products on the right. If you have more than one reactant or product, they are separated by a plus sign. So let's go back here. You'll notice we have carbon and oxygen. So that's why we have a plus. So we have two of them reacting. And then there's this delta sign, this triangle, that indicates heat is used to start the reaction. And so you'll notice where it's put if you use that there, that's heat over this arrow. So that's telling us that heat is used to start this reaction to make the product. And quite often the physical states of compounds are denoted in parentheses following the compound, as in solid, liquid, gas, and aqueous, which means dissolved in water. So notice carbon, solid, oxygen, gas, carbon dioxide, gas. That's what those things mean there. In table 7.3, we see some symbols used in chemical reactions. Our plus sign, which means that and that means the reaction reacts to form products, solid, liquid, gas, aqueous, and that we have heat that is used in the chemical reaction. Now, there is a principle that matter can neither be created nor destroyed. And so another application of that is that no atoms are lost or gained. So in our balanced equation, when we write an equation, we have to have the same amount of product atoms as reactant atoms. And so you go, well, how do I do that, considering they're different compounds or different elements, and how we do that? That's what we're learning how to do, and that is balancing the equation. And the way we do that is writing coefficients, which means the numbers in front, to balance out an equation. So let's look at this equation. We have our aluminium, we have our sulfur, gives us aluminium sulfide. Notice that on our reactant side we have 1 aluminium, 1 sulfur, but on our product side we have 2 aluminiums and 3 sulfurs. Obviously, that equation is not balanced. So how are we going to do that? Well, the first thing is count the atoms of each element in the reactants and the products, which is what we just did. Now then, step 3, which is the balancing part, is use coefficients, that means numbers in front, to balance each element. Now then, here is our compound. We have 2 aluminiums, so we can't put a 2 down here because aluminium all by itself is not written as Al2. When we're balancing, the rule that you need to remember is once you've written out the equation, so let me go back to this equation. Once you have written out the equation properly, you then balance it by writing numbers in front of the elements or compound as coefficients to balance it. So by putting a 2 in front of our aluminium, that is going to balance out the 2 atoms of aluminium in the products. By putting a 3 in front of the sulfur, that's going to balance out the 3 of our sulfur atoms. Now let's look here. State the number of atoms in each element of the reactant side of the following balanced equations. the reactant side and the product side. So the point here is they're just checking, can you do the math and figure out how many atoms of each element are on each side. So let's look at the first one. We have 4 P's here, and over here we have, for our products, we have 4 P's. And here I have 6 times 2 for our BRs, so that's 12 on this side, and I have 4 times 3, which is 12 of our BRs. Notice the reactants and the products of our P's balance out, and so do our bromium ions at 12. So when you do it with the other problem, problem B, you will notice that we have to balance, that of this balanced equation, we have 2 of our aluminiums here, we have 2 here. We have 2 of our irons here, we have 2 irons here, we have 3 oxygens here and 3 oxygens there. That's why it's a balanced equation. Now then, balance the chemical equation when solid Fe3O4 reacts with hydrogen gas to produce solid iron and water. So we have our equation here. Now then, let's first count. I have 3 irons on the reactant side, I have 4 oxygens on the reactant side, and I have 2 hydrogens. Let's look on the product side. I have, let's do it in the same order, I have 1 iron, I have 1 oxygen, and I have 2 hydrogens. So I need to balance it. Not everything's balanced. When we look at our problem, let's arbitrarily say, oh, look, I've got 3 over here. Let's see, if I were to put a 3 here in front of the iron, oh, my irons would be balanced. But that would still leave my oxygens not balanced. Okay, well, I have 4 here. If I put a 4 here, I would have my oxygens balanced at 4, but then let's recount my hydrogens. If I have this 4, that would be here. 4 times 2 is 8. Ooh, I have to come over here and put a 4 here to make those hydrogens also be 8. Let's look at that. Notice this is exactly what I mentioned. And it's balanced. Now, if we have polyatomic ions, when we do the balancing process, it's better to view the polyatomic ion that you recognize as its own single entity. So I'll show you what I mean. So balance the following chemical reaction. We have Na3PO4. Hopefully you recognize the PO4 as phosphate. We have our MgCl2. We have our Mg3. And in parentheses our phosphate PO4, and NaCl. Well, it's important and makes life much easier if, in recognizing the polyatomic ion that you memorized back at a previous chapter, oh, that's our phosphate ion, balance it as its own entity. Count it as its own entity. So let me show you what I mean. So yes, here's our sodium. There's 3 here. Notice, though, I don't count my P and my O separately. Why? Because it's going to make balancing much easier. Because you have a P and an O4, these same units still stuck together over here. So we have our PO4, one of them on the reactant side, and on the product side, I have 2 of these PO4s. I have 1 magnesium here, and I have 2 chlorines. Over here I have 3 magnesium on the product and 1 chlorine. So you go, well, where do I start? None of them are balanced. Well, you can you don't always have to start in one particular place. Let's arbitrarily, I don't know, let's see. How about we got 2 phosphates? How about we, since we have 2, let's go over here and put a 2 in front of this sodium phosphate here, so that I would have 2 phosphate units on my reactant side. So if I put a 2 right in front of the Na3PO4. The only problem with that is now I would have 2 times 3 sodiums. Well, there's no problem with that because that's called balancing. So now just remember, we're going to have 6 sodiums. We'll have 2 of the phosphates because we put a 2 here. Now that our phosphates are balanced out, you may think, how am I going to balance out the 6 sodiums? Because I had the 2 here, remember? 2 times 3 is 6. Well, come over here in front of the NaCl and let's put a 6 there. That gives me 6 sodiums on our product side, just like we would have the 6 sodiums on the reactant side. Now then we have 6 chlorines. And how? So we'll have 6 chlorines. Let's come over here. I have 2 chlorines here. How am I going to get to 6? Well, that's 3. 2 times 3 is 6. That means because I'm balancing, I use it as coefficients, I'm going to put a 3 in front of my magnesium, my MgCl2. So now then, my Mg is a 3. My Cl is a total amount of 6. Ooh, let's look at this next one and notice. Every single one is now balanced. Check to make sure. Now, on these A, B, and C, try to balance these out. I will provide an additional video showing the steps process doing that. So it'll be in a video following this. But right now, please give it your best shot and try to balance this. Balancing takes a little bit of practice. Here's the answers. But please watch the video that will be posted following this.